So Thomas didn't make it back. I had a choir kid last class. And Jacob didn't make it back. And Melanie didn't make it back. All right, here we go. Hopefully you guys are watching the videos. We're on this example. Who's missing? Uh-huh. Why is it 7 over 12? But what's C? Do you guys remember at the end of yesterday that the D idea wouldn't be very smart? It wasn't that it was a bad idea. It was a really good idea, but finding the distances using the definition of a hyperbola. Let me get rid of that whole triangle because that actually we didn't have enough information to solve. So the struggle is all we had was the vertices, which I have marked, negative 2, 1, and 2, 1. We have the random point 5, 4, which is a part of a branch. And then we figured out the center was the midpoint, so we figured out that was at 0, 1. And we had just gone to, hey, let's solve. So walk me through the algebra. How do we solve? Good. So what happens up top? 25/4. What happens over here? Equals. Ah, good job. Okay. When you include others' input, do you sometimes have mistakes come into the discussion? Okay. Life lesson. What do you do with it? Graciously respond. Maybe you just say, nope, wrong, and then you fix it yourself. Maybe you just exclude everyone from your group project and say, forget it, I'll do it. Or maybe you try to help them through the process. And maybe they'll find their own mistakes. Okay. We could subtract 25/4. Is anybody else a fan of multiplying both sides by 4b squared? Sometimes you just give your input because it'll be easier. It's okay. So multiply both sides by 4b squared. But be willing, if they disagree, to maybe not always do things your way. Okay. As we distribute, now we get 25b squared. Yeah? Minus, what's next? Good. Equals? Hey, go team. Let's just get the b squareds together, yeah? Double check my math. 21b squared is equal to 36. b is equal to 36 over 21 square rooted. Ugh. Double check my math. That's really nasty, but it could be nasty, remember? Yeah, I haven't finished, but I was making sure the 21. You guys all got 21 too? Bummer. Okay, so yeah, we'd have a plus or minus, and then we could go ahead and make that. Good catch. Plus or minus 6 over rad 21. No perfect squares there. Yeah, so we could go ahead and rationalize it if we needed to. But wait. Where's the b supposed to go? Oh, it's supposed to go up here. Hold on. I don't even want the b. What do I technically want? The b squared. So couldn't I just keep the 36 over 21 and forget all that nastiness? And just say whatever, let's just go plug that in? You could. You could do this whole rationalization, but looking back at the beginning, you're like, oh, I don't even need that. So then we end up with x squared minus y minus 1 squared all over 4. Wait a minute, guys. Why? Would the answer key have? I know, it takes some confidence to say what the answer key have, but maybe you shouldn't use that one. But why would the answer key have 21 over 36? Because if you divide by a fraction, you can multiply by its reciprocal. Not really. What are they asking? In a standard form? If we wanted to, we could make it all nasty. Remember yesterday how I was like, hey, what if you wanted to give someone an example that would really test them on this, of a hyperbola that they had to graph? You probably wouldn't give it to them like this. We would multiply it all out. So we could multiply both sides by 36. We could FOIL everything, get it all to one side, get the conic section standard form. But the clue standard form is so much easier. And to be honest, I'm pretty sure the back of the book, for the most part, is putting it in the x minus h squared over a squared form. Would you guys agree with that, those of you that have been working on it? Okay. So the only reason to keep going all the way is just to see where it comes from. What do you guys think? Just I don't know. I'm guessing. I haven't actually looked at it for technically a year. What do you guys think the last example probably is or has? Ready, set, go. So similar to an ellipse. Only a couple things are different, like the minus with the squared. So do what you can, thinking towards the ellipse, thinking back to the ellipse. Complete the squared, group stuff, move the numbers to one side. Let's see what you guys can do in your group. Sound good? Okay. I'm going to pause the video to give people watching it time to work too. I'm going to slowly start playing. Why did I just get a little concerned? Why should you be a little concerned? Equals 0? What do I want it to equal? Actually, I don't even want it to equal 1. I want it to equal something like 25 that I can divide on both sides by, right? Well, maybe not 25. That'd be gross. But I want it to equal a number I can divide. So what do I do? No. What did I tell you? If you get a 0 or a negative, you have to think maybe it's a degenerate. So if it's maybe a degenerate, remember the ellipse ones seem to be all imaginary, like they wouldn't exist. But hold on, hyperbola, what could I do? Can I plus or minus square root these? Yeah, they're positive. Remember with ellipses it was negative, but these are positive. So I can plus or minus square root. And when I plus or minus square root, well, it's kind of convenient. They're both squared. This one would be 4 times y plus 2. This one would be just x minus 1. Technically the plus or minus, some of you would think they would cancel out, but in all reality, you have to think about all the different combinations. Positive over positive, positive over negative, negative over positive, negative over a negative. You're going to end up with the possibility of still having a plus or minus. And when you do all the different combinations. Wait a minute, guys. What are these? They're lines. Right? Minus the 8 then divide by the 4. Except to divide the 4 would be, thank you. Everybody? Oh. So you could end up with y equals plus or minus 1/4 x plus or minus 1/4 minus 8. Could you keep simplifying? Yeah. You have to choose the positive, then choose the negative. So you'd have y is equal to positive 1/4 x plus 1/4 minus 8 minus 32/4 minus 31/4, I think. Maybe double checking my math. Where y equals negative 1/4 x minus 1/4, minus 32/4, minus 33/4. Look at those degenerates. But they exist. Intersecting lines. And remember, if you didn't take time, my non-artistic ones, you might not have this visually, but my artistic ones, maybe you do. You spend a little more time on it. Way back here, we first talked about conic sections at the beginning of 10-2, I think. It's one of those weird slices where you went straight down through the hyperbolas and you got the two intersecting lines. There you go. All right, cool kids. So then coming on back. Dun, 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 dun. 10-4. All right. Go back. Questions on this one, David? Oh, it might be. Hold on, double checking. Minus 2.
Because it's minus 8, it's the plus or minus parentheses x minus 1 minus 8 divided by 4. All divided by 4.
Talking about this one?
Oh, no, all the last step. What Joe was saying. More. There we go.
There's a 2?
No, it'd be minus 8, and since it's divided by 4, it'll be minus 2.
Oh, yeah, thanks, bud. I drew that line, but in my head I didn't mentally keep it there. Silly me. I'll move that 4 to where he should be, then I'll see it better. There you go. Good job. Well, that makes it a lot easier. Don't even have to use 32/4, huh? Just have to use 8/4. So negative 8/4 plus 1/4, that's the positive one, right? 7/4. And then negative 8/4 minus, good, would be 9/4. That's a little bit prettier. Well done. Okay, now we're at the intersection 10.4. Let me go ahead and have us at least kind of start 12.3. I'm going to freeze the screen after I make it kind of big, so I can go look at the calendar and make sure that we're staying on with what we need to do. True, except, has anybody looked at the homework sheet recently? And have you noticed that it says other book or other section? This is not actually from our chapter 12. So you might want to go ahead and put a quick note. It's not our chapter 12. It's a different book's chapter 12. And when I give you the handout, you're going to see 12.3. So I don't want you to be confused. I'm actually taking a quick timeout. And instead of doing R10.5, I'm doing an alternate section from a different book that I find to be a bit more helpful. Doesn't mean 10.5 is bad. And I'll show you the difference as to what we're doing versus what's in section 10.5. R10.5 says to rotate conics, and I agree that it's a good thing to know how to rotate conics, but I want us actually to revolve conics or do a different type of rotation. Instead of rotating in the second dimension, I want us to rotate in the third dimension. So I'm just choosing a different type of rotation for us to go over. All right, we're doing well. We're doing well. Okay, we're not going to do very much of this section. We will make sure that you guys have the homework from section 10.4 or for section 10.4 if you haven't started it yet. And for those of you that have started, we'll try to go ahead and get at least a couple questions covered if you've gotten stuck anywhere. But we are going to introduce 12.3 first. Now I know it's weird, 12.3. However, there is a method to my madness, a purpose for the change. I want you guys to get ready to draw the paraboloid. I want you to draw a parabola. You don't have to be super specific. But I want you to draw a parabola. You don't have to put the focus or the directrix, even though that is important to know from section 10.2. Okay. Checking out the chapter 10 homework sheet really fast. I'll get back to this in a second for you to write down 10.4, but just showing you what's going on. After 10.4, I choose to not do our 10.5. I choose instead to do a section similar in a similar chapter, even though it's a different chapter. Chapter 12 was its number, but in a conic section chapter, I'm choosing to take a different section from an old book that I used to use instead, hence the handout. So this is not our 12.3. This is the handout 12.3 that you guys have. And as you guys look at the handout, look at the very back of the handout or the last page of the handout. Ooh, it's the odd answers. Go team. Okay, so that's what's going on. Our test is going to cover for chapter 10A. Ooh, there's a 10A and 10B. For our chapter 10A, it's going to be 10.1 to 10.4 and then 12.3. Now, you might be like, well, what was 10.5 if that's what we're skipping? 10.5, ooh, what do you guys notice about our conics? They've been rotated. Does that make sense? They've been twisted. The axes are no longer horizontal or vertical. Now they're at different angles. Does that make sense? This would have been our 10.5. And it wouldn't have been bad. It would have been good in an ideal year if honors ever got a little bit more ahead than we are. We would have probably covered 10.5 and then this 12.3. But instead of covering this rotation, which is two-dimensional rotation, twisting the axes, the major, the minor, the transverse, the conjugates, etc., instead of twisting those axes two-dimensionally in section 12.3, the one of the handout that you have, ooh, I wanted this open in case we had questions on 10.4, Lo siento, one moment. This 12.3 instead, well, let's check out what's going on. I told you guys to sketch a parabola, right? My artistic ones, get ready to have fun. My non-artistic ones, get ready to do step by step, following a directions to try to pretend to be artistic. Did you draw a parabola yet? How many of you guys have gone to the animator studio in Disneyland? The animation where they, literally no one? You guys are so sad. They walk you through how to like draw, anyway, you guys should go, it's really cool. They walk you through like the big circles, little circles, and then you end up with some sort of variation of, let's see, my last one was Scrooge McDuck, I think. But anyway, okay. Well, that's not a good illustration. Coming back. You guys have a parabola, right? My illustration was going to be everyone can follow directions to at least somewhat get the idea. Doesn't mean it's going to be perfect, but to get the idea somewhat. Quick question, really quickly. Did anybody make a parabola going the other orientation in terms of y instead of in terms of x? Well, you could have. You could have. I wanted to say it would have been possible. All right. Paraboloid. A paraboloid takes a parabola and rotates it not two-dimensionally, rotates it three-dimensionally around, ooh, we're spinning the second dimension. And when we spin the second dimension, what do we get? Oh, Mr. Horn still has it. I gave him something to try to fix with a welder, and then I never got it back. Anyway, if we take, this is really sad right now, if we take a parabola and if we spin it, can anybody tell what's going to happen? Not a cone exactly, but you're close, a bowl. If you spin it, this parabola spun. You can. Let's make a circle, make an ellipse at the very top. For my non-artistic ones, ready? Boop! There you go. It's not very nice, but it would work. Like a tulip, like a bulb. See? Just put a circle at the top. And the circle should be going in the same orientation or having the same orientation as the rotation arrow. Now, if you guys want to be super cool, you could actually put a z-axis in. You could actually show this parabola actually spinning around that z and be like, oh, hey, there's the parabola. You could actually do like a cross-sectional slicey thing up here. You can make it cool like that. But anyway, long story short, you spin the parabola, you get a bowl. What's a snazzy name for the bowl? Paraboloid. This is all under the category of quadric surfaces. Not too insane. It's a lot easier to do with a pencil than it is with a marker and a smartboard. You could do shading if you want to have fun with it. You could show the spin if you want to actually go all out. Be like, hey, you're spinning. Spin, 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 spin. Anyway, we have our paraboloid. Now, let's go up at the top. There are two blanks we didn't fill in. Surface region and solid region. Surface region and solid region. Surface region. What if it was just the outer shell? What if it was just the outer shell? You had something, I don't know, back in geometry, maybe back in middle school math, probably geometry. You would have called this the surface area. Does that make sense? So you could talk about quadric surfaces just in the sense of or just referring to the outer shell or the surface area. But what have I drawn? What you drew, maybe it could have been the surface area. Maybe it could have just been the outer shell. But what did I draw? By showing the insides. Yeah, I showed the volume. I showed the solid region. So what if it was solid instead? Volume. This would be, what other way can you say it besides solid region? Filled in. That's kind of lame. The actual, yeah, it's the actual, right? I don't know, I think solid is the best way to describe it. That's how I would naturally describe it. The surface region, the outer shell kind of helps a little bit. I mean, you guys can think we just had Easter, right? So the surface region, that would be similar to one of those plastic Easter eggs. Open it up and hopefully there's stuff inside. Solid would be like, oh, it's one of the hard-boiled ones. Yay. Anyway, right? Because it's all filled in. So we have the surface region, which is just going to be the outer shell, or the solid region, which is called the volume. But how did I get this paraboloid again? By spinning a parabola. Can you guys look at the handout just real fast to get an idea of what's going to happen? Tomorrow, as we go more into this section, we're going to spin not just parabolas, but ellipses. Wait, but ellipse could spin around its major or its minor axis. I wonder if the shapes will be different. They will be. Hyperbolas. Hyperbolas can be spun around the transverse axis. Can anybody see two bowls? Do you see two bowls? If I spin? Or there actually is another axis that we haven't had to talk about yet. It's actually called the conjugate axis. You could actually spin a hyperbola around the conjugate axis. What would you guys get? Not quite. How about an hourglass? We'll see it tomorrow, but we can spin hyperbolas around their transverse and conjugate axes. But if you guys look at your handout, hold on. What's the beginning few questions look like? Look at the Q1, Q2, Q3, Q4. What are those? Ooh, they're like standard form thingamabobs. Completing the square, grouping, figuring out what it looks like, right? Why would, now I don't think I actually gave you homework on the Qs. Those were kind of like the intro questions. Yeah, ours starts down like the 1, 2, 3. But as you guys look at 1, 2, maybe look over at number 3, number 4, number 5. What do you have to do before you can ever start spinning? You have to actually make them. And are they as easy as just graph whatever hyperbola you want? They're specific. So we need to finish up section 10.4 homework tonight. That way we'll be ready tomorrow when we go to spin something. Well, wait, we might have to make it first and then spin it. We'll be prepared. So your 10.4 homework, if you guys want to write it down, if you haven't yet, it's gone. We should soon. I'm sorry, I had it and then I just closed it all out. Did anybody get stuck on anything in 10.4 yet? $13? $42? Oh, Patricia, that was a good question. Oh, maybe? No. There's 10.4 if you guys want to look at it. Sadly, my book kind of pooped out on me. 42. What's going on? Foci. So your center is 0, 0. Ooh, okay. The asymptotes, I know you see the rise over run of 3 over 4. But 3 squared plus 4 squared won't make 10 squared. So 3 over 4 was the reduced fraction. Think that could have come from maybe 6 over 8. And that will make your 100. That will match with your foci.